we have a little museum in South Florida. It's out of our home, and it's all over the house. And it's a collection that started about 12 years ago. We started finding these antique machines and wondering what they were and trying to do research on them. And basically, we found there was nothing out there and no information on them. And of course, we learned of all the complexities of different organizations over time and the banning of different machines and this and that. And we decided to try to find the truth, because what we saw, there was kind of two sides. There was one person that was pro every machine that ever existed, and there was another side that said, well, all of these machines are quackery and they were all useless. And we kind of set out to try to find a happy medium there and search more for the truth. And along that time, of course, we found eBay. And one of my greatest competitors on eBay, I later bumped into. A few years later, it's Frank Jones, and we're now good friends. And we decided if you can't beat him, join him. And this is our house. A little bit about the museum. We started collecting just as a hobby, and eventually it grew into bigger things. In the corner up here, you'll see some blueprints. One of the longest living company, actually, of electrotherapeutic equipment, H.G. Fischer, we inherited their archive when they went out of business finally in the 90s. Part of that collection was over 6,000 blueprints of early diathermy machines, X-ray machines, electromedical apparatus, and all of their floor model machines from the 1930s. And this was a bit of a surprise. We didn't even know they were still in business. But it proves that companies can exist, and if they try to remain as honest as possible, they can last even 100 years, even when all their competitors were closed down or whatever happened to them in time. The other part of the museum, we go back one, we have in exploring some of the research in the early inventors, we have an archive of one of the early pioneers. Actually, it took about 10 years. We found his home. In his basement, there were hidden some of the first high-frequency coils ever built. This is in the 1890s. And as part of that, an archive of glass negatives, and we'll show a few later of what he was doing. We'll start off first just about the earliest machines that were used. The main pioneer was Ben Franklin, who used them therapeutically, was the static machines. And we'll see a few here built. Many of you have seen the website arcsandsparks.com. This is Jim Hardesty, who's the master craftsman of these machines. And one of the rare examples of a machine that's very difficult to build, even though it's mechanically or in theory it's very simple. These were made first in the late 1700s, early 1800s. And they were still made at the turn of the century when to explore the X-ray, powering X-ray tubes. And one of the earliest pioneers was named William Benham Snow. And he wrote many books on the therapeutics of static electricity. Some of the earlier machines that were on the market, and starting in the 1870s, there's Michael Faraday was one of the early people to explore induction. And these are sort of the predecessors of the TENS machines. They're called Faraday medical batteries. And they're kind of crude by today's standards in some ways, but a few of the more elaborate models could be more accurate than some of the ones we've seen today. They were interesting, the different applications of these induced currents. Many of them had hand electrodes like you see in a lot of the machines. Even here there's some. And he had sponge electrodes, and they went as far as having electric baths where they'd install these plates on the wall, and you'd be in the bathtub with these wires going in, and your whole body would be treated at the same time. And of course, as any type of legitimacy was in the machines, there was always a few people that decided to pawn them off illegitimately. And one of the famous ones was these electretes, and they were actually curiously, the first machine that was ever banned It was just a small buzzer inside of one of these rollers, and as you would hold one end, and as you would roll this thing on your body, you'd get these horrible shocks all up and down your arms. They're an interesting device, but pretty nasty. Another early one, there was an instrument maker named Daniel Davis, and Davis, he was exploring all methods of physics and electricity and magnetism, and one of the machines he devised was a Magneto-Electric machine. And there was a Dr. Jerome Kidder at the time. They worked together, and they built these sinusoidal machines and dynamos. They were basically hand crank generators, and one person would sit there and turn the crank, and the other one would hold the handles and get shocked. And a lot of them had these amusing pictures that would be shown in the lid. And even more interesting were some of the claims. I mean, I've seen one machine in England that it claimed to bring people back from the dead when you used it on them. And they started off in the 1850s and were made up into the 1890s or so, and even a few after. One of the most famous people to employ these was John Harvey Kellogg, famous for the cereal, and the Battle Creek Sanitarium. We had to laugh. There was a funny movie, The Road to Wellville. I think it was Anthony Hopkins that played Kellogg. But they had a ridiculous mock-up of one of the original machines, and we had one just sitting in our living room the whole time. But you can see there's a motor generator on the top, and the generator, the output from the generator would be below. There'd be a rheostat to control the power and the speed. And we have an example down on the floor. We can show you that later. As these induction coils, the small Faraday batteries, were being used, they found that as they played with these machines, they were able to get higher and higher voltages. And for a while, there wasn't a real practical use for them until the discovery of the X-ray. But here you see one of the earliest pioneers was named Klingelfuss. And they were using these coils and producing these fantastic sparks. And it was a real art form in order to create these. Most of them were run from batteries, and you'd have something like a bank of car batteries, and all of a sudden you're getting these 3 or 4 foot sparks. What's interesting, some of these machines had as much as 40 miles of wire in them, and the wire was like the thickness of a hair. One of the first interests or applications of these machines was a kind of scientific curiosity called a Geissler tube. And these were intricate blown glass pieces that you could have, the elite would have them in their living rooms and demonstrate to their guests. And they were, for a short while, a real curiosity. And they eventually led to the discovery of Crookes tubes, which were a higher vacuum tube, and then suddenly X-ray tubes. And what we see in the corner here is Röntgen making his discovery. He was playing with one of these Crookes tubes, and he saw a piece of paper he had coated with a barium platinum-cyanide. It was glowing on the other end of the room, and he couldn't figure out why this thing was glowing. And it turned out that he was putting 2 and 2 together, and there was some sort of an invisible radiation coming out of the tube, and it was the discovery of X-rays. Here's a little movie of one of these Crookes tubes, and what it is, there's a high vacuum inside and like a little fan, and the radiation would actually cause the fan to move to the left and to the right. But as we go on to the discovery of X-rays here, for a while there wasn't a use for it, because they were more of something you would bring to carnivals, and people could stand and you'd have these fluorescent screens like Röntgen had, and you could hold them in front of your hand and put your hand in front of the tube and see all the bones in your hand. And you can wiggle your fingers and see exactly how your hand worked. And for half the population it was petrifying, and for the other half it was something really interesting. And some doctors put 2 and 2 together and decided it would be useful in practice for finding one of the first uses. It was the Spanish-American War, I think it was. They were finding bullets located in people. And for a while, for a long time, the dangers weren't really appreciated. And you can see that some of the earliest authors, the most famous was Morton. And here you can see a picture of this. It's kind of hard to see up here, but there's this man's going to have his hand x-rayed. There's some photographic film. And there's an x-ray tube up here. And what the physician's doing, he's just putting his hand up next to it and testing his apparatus to make sure it's working properly. And this resulted in x-ray burns for thousands of physicians. And it's interesting, it's sad really, many of the earliest authors of electrotherapeutics died even before the first decade of the century because of the complications from radiation exposure. This is a name, Elihu Thomson. He was a brilliant inventor at the time and rival of Nikola Tesla. And he played an interesting role. He worked with Edison, and they had become very interested in X-rays. And to the right, you see some special tubes here. It's kind of just a curiosity in history. There was been a battle since then who was priority in working with high frequency currents. Was it this man Elihu Thomson or was it Tesla? And as we go to the next slide, it was actually Thomson that published the first information, but it doesn't mean that he was the first to experiment with it. He devised a certain X-ray coil that used high frequency. And these are some of the original blueprints to that. And as we move on, there's an article here, Edison's new experiment trying to get the blinds to see with these X-rays. And he noticed that when certain blind patients were X-rayed, they would detect lights or flashes in some way. And so they were exploring possibilities of the X-rays curing the blind. And in the process, it's a long story, but Clarence Daly, Edison's assistant, became one of the first fatalities relating to X-rays, and he actually stopped the experimentation. But this is Nikola Tesla. He was known as sort of the father of alternating current and electricity as we know it today. It's a picture of him at Colorado Springs. There became a great rivalry between Tesla and Edison in the electrical spectrum, and it's interesting. There were many arguments and discussions of X-rays, what to do with them, how they were useful. And this to the left here, it's interesting. Electrical Review was one of the most popular magazines at that time for scientific discoveries. And they were asking Mr. Edison to elaborate on some of his discoveries and what he was doing with these rays. And he had wrote back, well, you have Tesla, that ought to satisfy you, and sent out back on their original letter. And another kind of a curiosity, they were asking, Edison's known in the battle of the currents with Tesla for developing DC machines, and Tesla was developing AC, but we have proof here that actually Edison was also experimenting with alternating currents when he found out that the Tesla system was superior. At first, they were exploring the use of X-rays. Both Tesla and Edison were developing these lamps, trying to find a new source of light using radiation. And Frank is probably one of the only people on the planet that has one of the lamps. And you can see that it's a single filament lamp, and it was being lit by simply X-rays. And it was a single wire lamp. And the whole idea of exploration with high frequency currents started with Tesla's lectures, because he sort of rattled the world with these lectures, and people were seeing arcs and sparks and strange phenomena that was unimaginable previously. And we reproduced one of his lecture coils here. This was just an example of one of the high-frequency coils that he exhibited at one of his lectures. And during that time, he started developing all of these different machines for different purposes. Some of them were for therapeutic purposes, some of them were for scientific purposes. And we've reproduced a few of these. And he reproduced all sorts of strange experiments. He mesmerized people with the wireless lighting. There's a small coil that we created here just to show the concept. You can see the coil's just attached to a loop of wire, and it's being energized from the circuit below. Losing the mic here. Okay, he created a lot of elaborate patents and machines, and these are Mercury interrupters to the left and right, to be able to handle these high-frequency currents and switch them at the power levels they needed to make efficient X-rays and efficient machines. And we did an example of one of these interrupters here. That's a 10,000 hertz coil. And some of these inventions were put to practical use. They had all of these elaborate circuit breakers to operate their machines.
We could get the audio on those. Where's your phone?
There, we got a little bit of sound. And as people began experimenting with these lecture coils and Tesla coils and high-frequency coils, they started to experiment with the circuits and create variations of them. And one of the first variations was how to simplify that huge static machine and produce an effect in something you could carry around and as a small suitcase. And here's a machine. You can see the sparks are very jagged. They would make your muscles twitch. It was still a high-frequency coil, but by making modifications to the circuit, you can have it act like a static electric discharge. The first actual commercial high-frequency coil was made by Knott Apparatus Company in Boston. This is officially the first Tesla coil ever manufactured. It was a little bit inconvenient, though, because inside this box, which was about this big, it had all the electrical components, a coil and a transformer and capacitor, but it was filled with kerosene. So you could hardly move the thing, and if you did, the kerosene would spill, and if you operated it with spilt kerosene, it would light on fire, and pretty soon you wouldn't have an office anymore. We did some... one of the things we've been doing is colorizing all of these machines so that you can understand them a bit more. We find a lot of people, when they see the black and white photos, they just pass right over them because they look boring. So these machines were actually constructed three-dimensionally using the standard engineering program, SolidWorks. And part of that's involved, as we build reproductions of them, we kind of need the blueprints anyway to start out. To start building things, and it adds a nice sort of visual touch. We're just showing the effects of the oil insulation here on the machines. Okay, you can close on it. Now, we mentioned the name Kinraide before. This man, he lived outside of Boston in a town called Jamaica Plain. And he became interested in science and these X-rays. He was one of the first to really, what he saw around him, and this is 1896. There was this amazing discovery, and everyone was interested in it, but no one was actually taking the initiative to market it in any way. And he was really the first to say, let's put this into something practical. And he was developing different chemicals that could be used in these phosphorescent screens. And these were the screens the physician was holding and could see all the bones in their hand with. And he was developing these in his basement. And he actually developed the first high-frequency coil that was widely marketed and produced. And you can see this incredibly strange discharge coming from it. This is an apparatus that was sold into the hundreds in 1901. And his reported salary was $50,000 a year in that year, which is a lot of money. And it was the first to come up with a practical use. And as we move on, we see that he inspired a few people to try therapeutic applications of these machines. This is a reproduction we built. There's only 2 originals that we know of, and they're both stashed away in Harvard. And after 2 years of trying to correspond with anyone there, they won't give us the time of day. So eventually we might be able to see them, but until then, we've built this reproduction, and incidentally, it took 10 years to find the information to build this machine, and a lot of digging into old books from the 1890s. But, you know, a picture of it operating. And I'm going to dwell on this just for a few minutes. One of the things Frank and I found is there's a lot of old pioneers, and people want to reproduce their work, but they start off with their own ideas of what the person was doing. And sometimes I think, well, it may be just our opinion, but we think you should really reproduce what they were doing exactly first before you try to modernize it. Because until you really know what they were doing, it's kind of difficult to know how you could improve upon it. If you've never seen the original or you don't know, then how could you say that something modern would be better? And the most difficult part of that, we know that the machines were made with silk-covered wire. And trying to find silk-covered wire today is almost impossible. There was only one person in the US we found that could do it. And we have a spool of it here, and that was the start of this machine. And the reason of the silk covering was the coils are very complex internally, and they require a lot of insulation. A small coil, 7 inches in diameter, could produce a spark over 8 inches long and just burn the wire to smithereens if it wasn't insulated properly. And that was the first part of the ordeal in reproducing something like this. And we have some slides just showing the techniques and the actual winding process that was in there. And the wire was insulated with beeswax and pine rosin, 2 natural materials that today it's kind of hard to find in large quantities, but people often say, well, why don't you just use epoxy or use polyurethane or something modern? And the reason is, when we were up in that home in Jamaica Plain digging, in the basement we found some original coils, actually 10 of them. And this is one of the originals to the left. And the insulation, it was, in these rooms, they were literally, the way his house was built, it was blasted out of rock. And in the basement there were these narrow rock hallways, and the floor was dirt. It was a dirt floor, leaves everywhere. And in the corner were these high-frequency coils that had been buried since the 1890s. And they were just moldy, rotting, in horrible shape, and yet they still operated, and they still worked perfectly, and despite being stored in the most unfavorable conditions you can imagine. And so suddenly, something that would be absurd to most people would realize, hey, this was a secret formula. It really works. And as we made this machine, one of the things we found, there were some very peculiar-looking sparks generated from them. And as we move on, now these are other components of that machine are a bit strange. For those that know what a spark gap is in a high-frequency machine, he had an elaborate water-cooled version. It was 6 inches in diameter. The average engineer of high-frequency machines today would look at it and say it's completely absurd. But we've reproduced it, and it works just fine. We actually have built some modern machines based on it, but we'll move on here. This is actually a modern reproduction that we installed in Prague in a technical museum. You can see the output of this. But this was a let me move back forward a few slides here. One of the things we found in his laboratory were these glass photographs. There were over 500 of them. Most were 8 by 10. And they contained these bizarre-looking electric forms. And we recognized some of them as being out of Tesla's lectures, and some of them we just never imagined before. And what Kinraide was doing, he was taking these coils and just experimenting with them to every degree possible. And in the process, he was making a kind of a photographic record of what they would do. And along that way, he inspired a man that first started working with X-rays named Frederick Finch-Strong. And Strong was one of the first people to walk down into Kinraide's basement and see the first chest X-rays. And the reason was that prior to that, no one was able to create a machine powerful enough to make those rays. And Strong was inspired to start experimenting with them. And he started off, he remembered Edison was X-raying the blind, and he had a blind patient, and he was using these different X-ray tubes and these different vacuum electrodes, Crookes tubes and Geissler tubes, and he was trying to see if this patient would detect anything. And the patient, there was nothing noticed for the patient on any of this, except that she had a migraine that disappeared. And Strong ended up attributing it not to the tubes he was connecting to the machine, but the actual currents generated. And he went on to develop the glass vacuum electrode, which is common to all violet ray machines we know today. But this was first conceived in 1896 by this man, and over the century there were hundreds of them made, and dozens and dozens of companies that made the machines. And Strong was the first physician to employ high-frequency electricity therapeutically. And when he first released his announcement, he was laughed at by his peers for about a year. And then suddenly, gradually, people started to experiment with him. And they found that, well, he's not so far off. And one of the questions we get a lot of times in the early machines is, was there some inert gases in the tubes? And actually, in all of the early electrodes prior to the 1930s, there was never any inert gases. It was just a vacuum. And the reason for the different colors in the tubes were how high of a vacuum you had. And the way it works, if you have a glass tube and you put electricity through it and it's normal air, you see sparks. And as you draw a vacuum, suddenly the sparks widen and they have kind of a reddish color. And as the vacuum goes higher and higher, it changes to a lavender and finally to a white color. And if you bring the vacuum down even further, you end up with X-rays, where the only thing that lights up is the glass of the tube. But Strong, he was a physician at the time. He taught at Tufts College in Boston. And he wasn't too handy as a machinist. And it's interesting to note, today, I don't know a lot of doctors that do metalworking and such, but back then it was common, actually. A lot of physicians had their own machine shops, and when their machines broke down, they didn't call anyone. They repaired them themselves. Strong went to the nearest place he could find, which was MIT, and he found a student who was working for Edison at the time, named Earl Ovington, and they developed the first therapeutic Tesla coils on the market. And we have a picture of the first machine that they built, and it was sold to the Massachusetts General Hospital for something like $200. And the funny story is that they didn't have enough money to get all the materials, so they just raided the dumpster behind the hospital and found all of the materials they needed eventually to build the machine. And this was actually a cabinet that they had pulled out of the trash, and the terminals on top of the machine were brass bed balls from the bedposts at the time, and all of the insulating rods at the top there were hard rubber syringes that they had pulled out of the trash and cleaned up. We built a reproduction of this machine, and it's interesting. There's a triple terminal on top of the coil, and by moving these plates to the left, you could adjust the capacity of the coil and change its frequency. And you'll see the glass electrode at the bottom. Strong was applying, he had charts of 20 different methods of using this machine and how he could apply the currents to people. And it looks harsh because you see these discharges 8 inches long, but he developed ways of applying them to the body, even though they were such a strong discharge, in ways that people could take without any pain. And you see just a funny picture of me looking through some of the ionized air created from the machine. The machine makes a ton of ozone. In fact, you can clear a room within a few seconds. It gets so powerful. Strong, California, I mentioned that just because all of the early electrotherapeutics started in Boston for some reason. Just a lot of people were inspired by each other and bouncing ideas off of each other. And you look in the old medical journals at the time, and you see the same journal where Strong was scoffed at years before. You see in the early 1900s, doctors were saying, "Hey, these currents really work," and they would publish information. We have a few of the journals down here, and they would say, "Well, I tried this for this skin disease, and it worked perfect." And another doctor would say, "Well, I tried the same machine, and out of 20 cases, 12 of them it worked, and a few of them it didn't work because of this and that, and how their machines were created." And it became interesting because the journals became a sort of a way of expressing what the doctors were doing, and it wasn't in such a way that they were publishing data and saying, "Okay, this is it, and this is what works." It was a way of sharing their own experiences with these new technologies, and if you can find these journals from the turn of the century, they're very interesting to look through because you'll see one doctor arguing with another doctor and about what machine, what apparatus they were using, and this inspired a lot of doctors to make their own machines and try to experiment and see what would happen with them. And here you see Dr. Strong and his wife, Ethel, with some of these machines that Earl had built. And they would travel around the U.S. Sort of doing an electrical show with them. And they all ended up in California somehow by the time they retired. But Earl, who was actually the man whose hands built the first therapeutic high-frequency machine, he was experimenting with these coils, and he did the first airmail flight in the U.S. He became interested in flying, and coincidentally after that, he had actually got the idea of being able to communicate to the ground using these coils, and the same variation of coil he was using to treat people with, he was using for wireless communication to the ground after that. So he was the first person to communicate from an airplane to the ground. And we mentioned a friend of ours, Bill Wysock. He's also living in California, and he's also, these men inspired him with Tesla. People will know Tesla technology research. Bill owns a very rare piece of history as one of the first alternating current motors actually built by Tesla. One of the next early pioneers is Curtis, Thomas Stanley Curtis. He had the idea of educating the public on how to build the machines, and it was something that people like Tesla and Thomson, they published these incredible lectures showing the machines, but for the average person, they didn't know how they worked or how they could make them. And Curtis had the idea of making magazines and showing exactly how to do the experiments in your own home. And this is a picture of him with some finished machines he built. And he built them for X-ray use, for therapeutic use, for even gardening. He had a special high-frequency coil to make better plant production and so forth. And some pictures of him working. We produced one of his machines here. We don't have to see the video on that. We'll go on. this was meant, as you look in the early books on high frequency, one of the strange things you see is that the definitions change after every so many years. And the word Tesla coil is often seen, but it's the real definition it's one of many, many types of machines. And there's no one definition to fit it. And at one point in time, this type of machine shown here is what it represented. Now we'll go on. After Kinraide built his machine with selling so many of them, suddenly other companies started to come along and make them. And one was called Campbell-Electric up in Lynn, Massachusetts. And they developed a whole series of therapeutic machines. From a small suitcase that could produce X-rays and do small amounts of diathermy, to even smaller suitcases that could do the same thing on a smaller scale. They even made electric chairs that people could sit in, and they were normally glass tubes lining the arms, and you had balls, spheres you could put your hands on and take all your treatments and relax. One of the next pioneers was named James Seeley. He was out of Los Angeles. He developed a whole series of different therapeutic machines. Here's one of the examples here. We'll show it in operation. And you wonder how that could be applied therapeutically in any way to a patient. But in this way, it was for X-rays. But there are other terminals seen on the front of the cabinet that could be used to treat people with skin conditions or with the glass electrodes. This is the Fischer company we mentioned because they were the longest surviving company. And we're going to demonstrate some of the techniques that they had in their machines. And this is interesting. It's one of the first violet ray machines ever made. And it's the only one, to my knowledge, that was never banned or never taken off the market, just because they were very specific in their books what ailments it could cure and which it couldn't, and they were a little more careful in their wording. And they, as a rule, in all of their books, they put claims to all their machines, but they were very specific in how to operate them, and they never exaggerated the claims in order to sell more machines. And that's where every other company kind of went wrong at that time. They let the quality of their machines speak for itself, and instead of over-exaggerating. And then they had salesmen all over the U.S. And surprisingly, they lasted until just a few years ago. And of course, they weren't making violet ray machines anymore, but they had progressed over the years. The diathermy machines changed. These original spark gap machines that we're going to show changed as the technologies changed over the years. They went to shortwave next, and then they changed to ultrasonics after that, and then microwaves after that. And but it's interesting. There are still these spark gap variety of Tesla coils in hospitals today. They're just so well hidden that not the operator or the doctor or anyone knows what they are. And they're in cautery machines. It's almost standard to have a spark gap Tesla coil still. We're going to show a couple of videos here. The output from the coils, the first major use of these was for removing of tumors, especially cancer. They found that the currents, they were interesting. At that time, the only alternative was the scalpel. And when removing cancer, they found that as you were cutting away tissue, it would bleed, and that would reinfect other parts of the body with bad cells. And if they had used this electricity, they could do all the surgery and cut away all the tumors and cysts, and at the same time seal the blood vessels so there'd be almost no bleeding. And this had a much higher success rate than anything ever done before. And in the early books, they said to the doctors, always experiment on steak before you moved any patients, because you don't want to do any permanent damage. And so we said one day, hey, we're going to try it out. And here's an example of it, cooking the tissue instantly. And it looks crude, but it's not far off from a modern laser being used. You can see these are actually literally the instructions of electrocoagulation. You know, you're going to remove a cyst from someone. Here's the first thing to try. Stick an electrode in a piece of steak, turn it on this way, adjust the machine this way, and you see what happens. And so when you move to your patient, you're not going to fry them accidentally. And Fischer went on to make a lot of interesting machines. This is a very intricate machine down here. It's a wave generator. It's called low voltage generator. And on the front of the panel, on the top of the machine, you see all different waveforms. And they go from sinusoidal waves and square waves and sine waves and direct current waves and pulse direct current and all different modalities of muscle stimulation and so forth. And the machine is right here, and the rest of it's just a cabinet of accessories. And to produce these waves, it was actually a motor and a generator and a system of mechanical brushes. And the waveforms were very pure that was generated from the machines, and it was all done through mechanics. There was no electronics at that time period to be able to produce all of this. And that tiny box on top of that cabinet weighs about 150 pounds. But it's an incredible work of art as far as the engineering is concerned behind it. And to the left, we see one of their early X-ray machines. One of the early doctors to experiment with the low voltage currents was Frederick Morse. He developed this interesting machine where it was another motor generator set, but there were all of these different shaped cams that would fit inside of here, and it would affect how the machine rotated, and how the machine rotated would affect what kind of current was being produced. And he published a lot of interesting books on intestinal disorders of people and how they were cured using this machine. And he showed all the different techniques of applying the electrodes. He showed the waveforms. He showed X-rays of the people before and after. And it was an interesting approach, and it opened a lot of people's eyes to what low voltage currents can do for people. I mentioned as the technologies changed, the machines changed, and it gets curious. This is a shortwave diathermy. The problems they had, and this is something we have some paperwork. It's almost never mentioned. At one time, any spark gap machine or diathermy was banned, and we all know, we've heard the story that they're banned, but very few people know why they were banned. And the reason was because of AM radio, for the most part. There were illegitimate people selling them, and they were called quacks and taken off the market and so forth. But the legitimate manufacturers, at one point they were stopped, and they said that there were some restrictions to using the machines. And what the restrictions were was that people were listening to AM radio. It was the age of listening to radio programs at night. And universally, in every newspaper across the US, there's an article that you can no longer use your violet ray or diathermy machine. But the conditions were from 7 to 11 p.m. And that's something you never hear. They weren't taken off the market in any harsh way. It was just that they were interfering with people's radios. And the only people that were allowed to use the machines during that time period was emergency room surgeries with this surgical type of equipment. But it's an interesting part of history. And even these machines, they changed the shortwave because they were causing less radio interference, and they had certain frequencies that they could use that wouldn't interfere with communications. And that's another side of it was during the Second War, there was a big issue with espionage, and the fact that almost all of these machines, I mentioned Ovington, he was using a variation of his therapeutic machine to communicate to the ground with people as he was flying. You can modify these machines and use them to communicate with someone else, like a ham radio or like a wireless telegraph. And the big issue was, were spies, were there people in the U.S. going to use these against the U.S. or as spies somehow? And in order to regulate this, they tried to keep track of all the machines. You had to have FCC agreements, and it became more complicated. And that's a lot of reasons why some of the legitimate companies in the 30s sort of fell out of use. Aside from the Depression, there was many restrictions, and it became harder and harder to buy these machines, to keep track of them, and to know who had them. And it's just a sort of a strange part of history. This was one of the greatest machines here. We have a friend in the audience, Herman, that came all the way from Belgium that bought one to talk about it. This was a floor model Tesla coil. It was just fabulous. The company was McIntosh, and they started off in the early days making galvanic sets and batteries in the 1880s. And here's Frank next to his machine. And the machine, it did kind of everything a physician would need is in one cabinet. It could produce X-rays, it could be used for therapeutics, and it could be used for surgery or cautery or all sorts of different techniques. Oh no, this is a violet ray machine from the same company. I didn't have a video of the Hogan there. By the 20s, violet ray machines were becoming popular for home use. Almost universally, any machine that had any legitimacy in medicine was pawned off, in a sense, to people to try and use in their homes. And the problem with that is a lot of times the books that were sold with the machines, they would put claims to them that was used in the larger apparatus. And a lot of times, while it's true something could be cured with high-frequency currents, it wasn't necessarily true when you were using a machine that was only 20 watts of power. And this is where a lot of them companies were shut down, because the claims that they put were, in some cases, impossible. And we have a silly video here of an ozone generator from one of these machines. And there was a glass tube version where you could inhale the ozone as it was being generated. And the next version is a mask that you could inhale. But as you see, it's hard to tell. My cat is here watching the whole time, and we're having a laugh because the cat actually loves these machines and can't get enough of them. But as the 20s and 30s progressed, there was so much experimentation with spirals and inductive fields, and we have I forget the Frenchman that did the top one. There was Rochefort. There was adaptations of D'Arsenval and Paul Whedon, and these spirals were done by a man, W. Hyacinth Guilleminot. And a lot of people are interested in the inductive fields that can be generated from the machines. And Guilleminot was actually the pioneer of that. And there was something, autoconduction, where patients were placed in a huge cage of wire. And they would be, the field generated from the coil would have an effect on them. Here's the actual machines. This is a D'Arsenval coil. This is one of the first Tesla coils made in France. This is an Issenthal Whedon resonator. Just various types of high-frequency coils that were marketed in Europe. At some point in time, we tried to reproduce all of these and experiment with them. And these were kind of crude homemade versions of what we saw on the previous page. Here you see something, auto-conduction. You can see this huge spiral of wire that's energized and someone receiving a treatment inside. And after that, they found it was so much easier just to have the person lay on a metal plate on a couch. And it's interesting, with the way the couch worked, there was a metal plate on the bottom of the couch, and there was a very thick cushion, and then there was the patient on top. And the metal plate and the patient were attached to the machine, and they would form a huge electric capacitor with that. And what they found is that it would lower blood pressure. And even though it was only a temporary effect, at a time before they had the medications, it was one of the best methods to lower blood pressure. And it fell out of use not because of it was wrong or it didn't work, but more as the technology changed in the 30s, the shortwave machines couldn't produce the right type of current to do this properly. So it kind of just fell off the map. And we mentioned this is Dr. Henry Pifford. He was one of the first people to explore high-frequency currents in skin diseases. And these were the machines he made. Interesting enough, we got a visit one day from the American Dermatological Association at the house, and we thought, uh-oh. We didn't know what to expect because anytime someone from the organization shows up at the house, some people tend to worry, but to our surprise, they were looking at all the machines saying, well, there's nothing quackery here, really. He said, because all the concepts were legitimate, and they admitted wholeheartedly that these machines were used therapeutically and that it was the people selling them that were the problem. And I asked them about the violet ray machines because you still see them. They're still marketed for estheticians today treating acne and different skin conditions, and what his opinions were on it. And he said that there was some talks actually about possibly admitting faults of the past, where they were maybe going to admit that some of these machines were authentically useful. In the process, though, there was, of course, a lot of politics involved, because maybe they were going to limit, maybe some machines could be sold again, but under some conditions that a licensed dermatologist was the only one that could use them and so forth. But it was interesting to hear one of the first times admissions that, well, yeah, they were banned, but they weren't all quackery, like it was said. And we continue on. This is the last slide here. It's just of a large coil. And we're going to go straight to the toys after this.